Hi everyone, today let's try to solve a problem on projections of planes. It's the first problem. We have the question like this. An equilateral triangular lamina of 25 mm side lies with one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. Draw the projections. Here we have an equilateral triangle of 25 mm sides and it is resting on one of its edges on HP. Now let's try to solve this on the software. We'll draw the drawing platform. First, we'll set the sheet to A4. For that, we'll right click out here, sheet setup, click on A4, uncheck the background, save as default, and then click OK. Then fit. Now we have the A4 sheet here. Now we'll take the line as normal line. We'll first draw the XY line, name it out in caps, X over here, Y over here, VP and HP here. Once we have the namings, we'll place it at the desired positions that we need. Now we'll take the line again, we'll take it as visible line. So we'll draw a triangle right here of sides 25 mm, 25, enter. I've kept my alignment indicator on. I'll place it here straight and then with the center out here, I'll just give the angle length as 25, enter and hit again once again enter and then join it out. This is one method of drawing the triangle. So the different methods of drawing the triangle have been explained in another video. So now we'll take the normal line, we'll project the line upwards till here till it turns red, and from here I'll use the alignment indicator. I'll draw the excess lines, then I will trim the ends here. Then after that I'll change the line to visible. From the end of this line to this particular line I will draw an overlapping line which indicates the front view. Now here this particular point is A, this one is B and this one is C. Here this one is B dash bracket B dash bracket A dash bracket close. A dash is in the bracket because it is hidden. Here it is C dash. We'll take the line up point upwards so that it is visible. We'll place all the points at the desired positions. Now here the dimension of this particular triangle is 25 mm. We have to show that. Now, so do the next part. In the next part of the question, we have the lamina. The lamina is inclined to HP at 60 degree and VP at 60 degree. Now, we'll measure the distance from this particular point of the line to this particular point. It is 21.65. We'll take the line. I'll start from here. We'll give the length as 21.65 and the angle as 60. Hit enter. Then we'll change the line to normal line and we'll draw the projections downwards. And from the base of this line, we'll draw the projection downwards. Now, from here, if we name it, we'll copy this name, press hold the control, click and drag and place it out here. We'll have the copy. Press hold the control, click and drag. We'll have the copy of the namings. Now, once we have the namings, we'll change the to line from here till here it is A B, and from this point to this point it is B, and from this particular point to this particular point is C. Now we'll trim the ends of the line so that I'll get the end points correctly, which helps me to draw the visible line clearly. From here till here it is visible, then till here, and finally till here. Now it actually completes the second part. Now here we have to measure the angle, that is the angle between these 2 points. See, the angle here is 60 degree. Next, again we have to draw this particular triangle tilted at an angle of 60 degree with respect to VP. For that, I'll select the select tool and drag a box and select this triangle. Now I'll press hold the control key and click on any one particular line and I will drag it out. So it will create a copy for me. Now I'm going to use a rotate command. So here in the rotate, I will select the rotate command, and in the position angle, so here in the position angle, we have to give the position angle. Now here for that, I'll select the pivot point. I'll select this particular point as a pivot point, and this is the point on where I have to rotate. This particular end has to be rotated in this way. Now here you can see the copy is on. I will uncheck it. So now in the position angle, rotation angle, nothing I am going to give. In the position angle, I am going to give it as minus 60 as I need the angle downwards. See here, I got it, and I will place it here wherever I need. Now if I measure the angle of this particular line and this particular angle, it is 60 degree. Now we'll change the line to normal line. We'll project the line from this particular point till here. Then we'll project the line from here till here. Before that, we'll do the naming of the parts. So here I'll hold the control key and then drag the namings. One A is out here, another A is out here. Similarly B, another B is out here. Let's check for C, and C is out here. Now we'll take the line again from the point A to the point A here. I'll draw it once again. So this particular angle is creating an issue, so we'll delete it and we'll rename it the angle later. From here till here it is A, and from this particular position to this particular position, from here till here. Now we'll trim the ends of the upper line so that the line joins correctly. Here we have the point A to B, from B to C, and then from C to back to A. The thing that we left out here was the angle out here. So here once again we'll give the specified angle. The angle is 60 degree. Now the naming is still pending. So here we have the naming as A dash, and this particular point is B dash, and this one is C dash. Now we'll place the namings correctly so that it is visible. Now this actually completes our problem on planes, the problem number 1.